this video I'm documenting the performance of an algorithm to calculate the distance between two words. The algorithm is known as Levenshtein algorithm. We can find information about it on the internet. And here I have an implementation of Levenshtein using the classical approach as it is found in the Python community. I have pre-created a list of 10 million random pairs of words where I'm calculating the distance between these two words. In this program, in this pilot program, read file, I am processing 500,000 lines from this file. For each line, I am calculating the distance of the two words. The results can be seen here. In our case, we processed 500,001 lines containing pairs of words, and the duration was 48.8 seconds. I implemented the same algorithm using plain C language, and this is the algorithm that I implemented it in plain C. There might be some minor micro optimizations that I'm missing from here. In this case, I am testing again using 500,000 words, pair of words coming from the same file, exactly the same file. And in this case, the whole file, the whole 500,000 lines are being processed in 0.1 seconds. It's not a mistake. Meaning if you run it, it takes 0.15 seconds to process 500,000 pairs, where the equivalent Python implementation takes 48 seconds, 48.8. In other words, if we want to calculate the difference in speed, is 48.8 divided by 0.15. So the NCC algorithm that I wrote, the improved algorithm, which is also implemented in standard C, is 325 times faster. Now the next step, what I'm going to do, I'm going to take the C library and I'm going to create an extension that I'm going to use it directly from Python, and then I'm going to compare. I'm going to use this for a spell checker that I'm going to compare against an industrial spell checker. and let's see how the performance is gonna be. For now, we have an algorithm that is promising too much. It's tell us that it's 325 times faster than the original one. And taking consideration, the reason I didn't try millions of words was just because the temperature of my CPU was going very high as I was running the Python algorithm with a big number. Let's say I put this to be a very big number. It's going to take a very long time, but the bad thing is that the temperature is going to start climbing up, and it's going to go to 60s and more, and I don't really want to risk, any damage to my CPU, and that's why I didn't allow this to complete for large number of pairs. Let's see how it's gonna go with the final spell checker algorithm.